Which of the following molecules is chiral? To determine if a molecule is chiral, you should look for chiral centers. A chiral molecule means that the mirror image of the molecule is not superposable on itself. You can think of your hands, for example. If a molecule has at least one asymmetric chiral center, then the molecule is chiral. Chiral centers are sp3 molecules that have 4 different substituents. Let's look at an example. In A, you can see that this green carbon is actually not a chiral center despite it being dashed. This is because the carbon does not have 4 different substituents, because there are 2 identical methyl groups attached. In B, the circled carbons are chiral centers because there are 4 different substituents, but there is an internal plane of symmetry. We can see this more clearly if we rotate the bond between the 2 OH groups to get this. Here we can clearly see that there is a plane of symmetry. This type of molecule is referred to as a meso compound, because despite there being chiral centers, the overall molecule is achiral because of the internal plane of symmetry. C is very similar to A because the circled carbon does not have 4 different substituents because it has 2 identical ethyl groups, making this molecule achiral. Finally, in D, there are 2 points of interest: the blue carbon and the green carbon. The blue circled carbon is actually not a chiral center because there are identical methyl groups, so it really shouldn't be wedged or dashed in the first place. However, the green circled carbon is in fact a chiral center because it contains 4 different substituents: an OH, a methyl group, an H, and the entire rest of the alkyl chain. Since there is at least one chiral center, the entire molecule will be chiral. Therefore, our answer is D.